I just want to make sure that we're using the compound interest formulas correctly because we haven't done them, I think, since like virtual. So Margie wants to invest money into an account and have $60,000 in the account by the end of 30 years. So here are three different scenarios, or two different scenarios. First, what if the account earns an annual interest rate of 2% compounded monthly? How much does she need to invest now? Or if the account earns 1.5% compounded continuously, how much does she need to invest now? And then I'm going to skip part C for now. So let's do A and B. How would I set this up? She needs to have $60,000. That's your A. That's the amount that you need. P is your principal. That is the part that we don't know how much she needs to invest. So now we need to fill in the rest of this interest part. So you still use the 1 plus. R stands for interest rate, 2%, so 0.02. It's compounded monthly. So you divide that by 12 because you don't get 2% every month. You get a 12th of 2% every month. And then how many times does it get compounded? 12 times 30. So 12 times 30 is your exponent. So this is actually not that hard of a problem because P is being multiplied by all this stuff. So if I can get what all of this stuff is equal to on my calculator, can I just divide that amount to the other side to get what P is? Right, so this circled thing is a number. Take 60,000 and just divide by that circled number. See if you can get what your investment should be. Yeah, because it's what your nest egg is. You're only getting 2% a year for 30 years. So your nest egg is around 32,000. Yep, that's the right answer. All right, so let me show you what I typed into my calculator. So I did this number first, and then I did 60,000 divided by my answer. Can you see where you didn't type it in the same way that I did, maybe, or? Did you round the 1.82? Oh, I'm wondering if you didn't put something in parentheses, or I don't know. Does anyone need me to check again how they did it on their calculator? You were all able to get the 32,000 answer now? Okay, so part B, how different would it be if instead of 2% compounded monthly, you only got 1.5% compounded continuously? You want to use the other formula at the top of the page. That's for continuous interest, right? So 60,000 again. We don't know how much to invest. And then it's E to the R is 0.015. We're still going out 30 years. Oops, you can't see what I'm writing. So again, this is just a number, right? E to that power is a number that you can actually divide to the other side of the equation after you evaluate it. E to the 0.015 times 30. Well, what if you inherited some money and you just said, I'm just going to put this 20,000 in an account and forget about it? How much would you have? You know, I would say you'd probably want to put it in like stocks because that's like 8% or more per year over time. Yeah, but on average, the stock market over a 10 or 20 year period, 38,257. Did you get that? Okay, so that's just working again with those interest formulas. If Margie decides to invest 45,000 in an account that earns continuously compounded interest, what annual rate does the account need to earn to still have 60,000 at the end of 30 years? So we have to figure out the interest rate. So this is going to use our knowledge of logs this time. So we want to get 60. We're starting with 45. E, I don't know the interest rate. And then 30 goes up there. So try to solve that using, it's kind of that same process as bacteria growth or decay. See if you can get what your R value. Mm-hmm. It's 0.00959, so it's about 1%. All right.